NASA's Voyager 1 spacecraft holds the title of the most distant human-made object, having successfully reached interstellar space. Imagine launching a spacecraft 45 years ago and still exploring areas that were never thought possible. This is the incredible reality of a bold NASA mission that is redefining space exploration. What's even more fascinating is that this brave spacecraft is not just millions of miles from its launch point, it continues to send data back to Earth using technology that is older than a cassette player. Launched in 1977, Voyager 1 recently made a discovery that has shaken the scientific community and captured the attention of the world. What could this amazing find in the far reaches of space be, and what does it mean for us here on Earth? A key moment in history occurred when two of the most remarkable space missions ever launched, ushering in a new era of space exploration. Thanks to the brilliant mind of Gary Flandreau at NASA's Jet Propulsion Laboratory, an ideal route was mapped out for the probe to reach the distant planets, Jupiter, Saturn, Uranus, and Neptune. Using only a pencil and 21st-century engineering tools, Flandreau made a startling discovery in the late 1970s and early 1980s. The four gas giants would align in a unique cosmic configuration, creating a kind of celestial necklace with Earth. This alignment would allow spacecraft passing close to each planet to gain speed through gravity, as if being pulled by an invisible rope. Thanks to this gravitational aid, a journey that would normally take 30 years from Earth to Neptune was reduced to just 12 years. However, this alignment occurred only once every 176 years. Faced with such an exceptional opportunity, NASA acted quickly. In just 15 days, they launched two identical spacecraft, Voyager 1 and Voyager 2 in the summer of 1977, aiming to take advantage of this cosmic alignment. Little did they know that these twin explorers would break all records in the history of space missions. More than 45 years after their launch, Voyager 1 and Voyager 2 are still operational, sending back information daily from the edges of our solar system. These brave probes have become the farthest ships in history, having traveled far beyond what was initially imagined. This is impressive, considering their original mission was planned to last just 4 years. However, these interstellar pioneers had plenty of surprises in store. At the start of their epic journeys, they provided us with incredible close-up images of the moons of Jupiter and Saturn, revealing worlds far more active and dynamic than anticipated. The discoveries of active volcanoes and ice fields forever changed our understanding of these distant corners of the solar system. Voyager 2, in particular, was the first spacecraft to approach Uranus in 1986 and Neptune in 1989, becoming the only probe to exist between those planets, surprising scientists with astonishing findings in previously unexplored territories. More than 14 billion kilometers from Earth, these Volkswagen Beetle-sized probes have defied all expectations and continue to expand the boundaries of our knowledge. The Voyager journey began with a gravity assist maneuver around Venus, a feat never before attempted by any spacecraft en route to Mercury, making them true pioneers. The journey to Jupiter took the spacecraft 10 times the distance Mercury is from Earth, and they had to pass through the dangerous asteroid belt. This was a feat previously tackled by Pioneer 10 and 11 probes, but the challenges didn't end there. With just 69 kilobytes of memory, a fraction of the capacity of a modern smartphone, the onboard computers had to rely on their own intelligence to manage the complexities of this extraordinary journey. Data collected by instruments aboard Voyager was stored on track tape recorders before being transmitted to Earth via a transmitter that only used 23 watts, about the same power as a light bulb. Equipped with 12-foot diameter satellite dishes, the probes facilitated communications using light-speed radio to send and receive messages. However, the increasing distance from Earth, advancing at 3 to 4 light seconds each day, presented major challenges. For example, signals from Voyager 2 took more than 18 hours to reach Earth. Increasing background noise from radios, televisions, cell phones, and other sources made it increasingly difficult to pick up the faint signals from the spacecraft. Despite these obstacles, the Voyager probes have defied expectations and continue to amaze astronomers with unexpected discoveries in an interstellar void. Their journey has rewritten our understanding of the cosmos and altered our view of the unknown. Beyond our solar system lies the enigmatic Oort cloud, a vast congregation of comet-like objects held together by the Sun's gravity. Although the Voyagers are still moving slowly towards that distant realm, their entry into interstellar space began when they crossed the heliopause, the boundary between our solar system and interstellar space. This boundary was initially estimated to be about 50 astronomical units from Earth, and funding for the mission continued as it neared that milestone. However, crossing this boundary did not detect an immediate change in the environment, leaving scientists baffled. The passage into interstellar space was expected to be accompanied by an abrupt increase in the number of cosmic rays, high-energy particles traveling at nearly the speed of light. Most of these rays are deflected by the magnetic shield generated by the heliosphere, which protects our solar system from external threats. The Voyager missions have not only expanded our knowledge of the solar system but have also raised new questions about the nature of the universe. As they continue their journey, they send back data that scientists are still analyzing. Each piece of information helps us understand more about the cosmic environment beyond our solar system. The Voyager missions have inspired a new generation of scientists and engineers. The challenges faced by the Voyager team have led to advancements in technology and a deeper understanding of space exploration. The success of these missions has shown that with determination and ingenuity, we can achieve what once seemed impossible. As we look to the future, the legacy of the Voyager missions will continue to influence space exploration. New missions are being planned that will build on the knowledge gained from Voyager 1 and Voyager 2. These future missions aim to explore even more distant regions of space, seeking answers to questions about the origins of the universe and the potential for life beyond Earth. Thanks for watching.